All right. I was about to set this down. I bet.
There's no real way to. We can't mess with Chase's stuff. Yeah.
Been, yeah, sir. Yeah.
You could set it down if you want to.
No, that's okay. I don't think that we have anyone presenting today who's about this tall.
I'll just present around it.
Yeah. Is it okay?
Yeah, it's fine. It's fine. I was just like, I felt a little weird standing for it, but like everyone can see me, I can see everyone, so
then,
I'll be fine.
Yeah.
I'm not worried about it.
Okay, we still have a few minutes to go.
Yeah, I'll just hang out up here and talk at the microphone.
I'm glad you're going first because. Okay, so I'll speak loudly because I don't have the microphone. But, ladies and gentlemen, welcome you on behalf of the Computer Science Department to the 2018 Capstone's final day. Professor Mahoney and I have worked hard on getting the people here, but I suspect the people themselves presenting worked even harder. And the Capstones represent an embodiment of the 4 years of time here, and then are intended to go a little bit further. And I am very strongly of the opinion that everyone's work fills both the spirit and the letter of that mission. Without anything else, let me introduce the first presenter. I'm not going to say Noah. Okay, Jonah Larson.
Hello everyone, like Perry just said, I'm Jonah. My project is VirtuPool. So, starting off with, I guess, my senior capstone, my question was, how can one play pool without a table or adequate space? Basically, I was trying to find a way to take an actual pool table and make it something portable, something you can put anywhere or use in any sort of situation. So, first off, what is pool? Pool itself is a variation of the English game of billiards, which was invented like in the 1500s by European nobles, and it was actually a yard game initially, and they moved it inside and added the pockets in the 1500s. Later than that, and then it evolved into 8-ball pool, which is the generic American pool that you guys all know, was invented in the 1870s. 8-ball pool is just pool with 16 balls, 7 stripes, 7 solids, 1 cue ball, and then the 8-ball. You have to score all the target balls and then sink the 8-ball to win the game. And then sinking the 8-ball early results in an automatic loss. Sinking the cue ball forfeits your turn, puts the cue ball back on the table. What is VirtuPool? So VirtuPool, my project, is an augmented reality implementation of this classic game of pool. So I have a virtual table, virtual balls, and then my physical cue stick here. What is augmented reality? Augmented reality is a technology that superimposes computer-generated images onto the real world and then allows you to interact with them with physical objects. So how does VirtuPool work? VirtuPool is comprised of basically 3 different processes working together in unison to create the overall project. There is the motion capture, motion tracking, which is done with the camera, which tracks your movements in real time to influence the game. There's the graphics rendering, which draws the table and the balls. And then there's the physics computation, which determines where the balls should go when you hit them and when they collide with each other. So the calibration, this is what the calibration screen looks like. It's a giant white screen with text at the top and a button on it. Really all the calibration is just making sure, so when the camera is set up, it is looking up at the table at an angle. So you have to adjust the image that the computer is using so that it's a square again. It's not a trapezoid because it keystones. So calibrating the table location, the way it works is you just literally, I start up the project, I run the thing, and it finds the cue. So, yeah. And then the gameplay itself is just shooting the ball. Sorry, my GIF started a little early, but essentially you walk up to the table. Once the game is done calibrating the ball, you can then line up your pool cue with your target ball, the cue ball, and then shoot. And the ball goes and hits the other balls like a real pool. The menu, again, screen with buttons on it. Really exciting. So the graphics is built using OpenGL, the Java implementation of OpenGL, which is JOGL. And graphics is interesting. It's different from a lot of other computer science things in that it's built with a lot of plumbing and a lot of little triangles. Essentially, you have to tell the computer like all the colors, where everything is in a 3D space, a 3D world, essentially. So even the spheres on the screen are just built with a sequence of tiny triangles. The physics calculations for VirtuPool are done with JBullet, which is the Java implementation of the Bullet physics library. And the way that the physics works is, again, you build a world in a similar way that you build the graphics, but there's no rendering for it. You have to create the objects, you create your own gravity, you create the friction, you add all of those things in, and then it does the calculations, and then I can map those calculations onto the graphics to show it on the screen. And then, in my case, I'm using multiple worlds. So when you go to shoot, it shows a little tracer line of where your shot's going to go once you shoot. So once you aim, it generates a second world, guesses where your shot's going to go, and then draws it on the screen for you. And then finally, the motion tracking, which is kind of the piece that brings everything together. It just basically takes in the images from the camera, reads them, and calculates locations of objects based on HSV and Huff circles. So HSV is basically a hue value saturation. It's the color and the intensity and the lightness and darkness of objects in the real world. And the reason that this is important is because the lowest level of value is 0, and that's black, and the lowest level of saturation is 0, and that's white. By adjusting these hue and saturation values, I'm able to eliminate the blacks and the whites from the images and then focus in on specific colors, so I can track just tiny objects on the screen, such as my markers on my cue, which are a very vibrant green, which isn't also in the scene in any other place. So what you see when the cue is in front of the screen is just this, but then what the processing actually sees is just those white boxes. All it sees is the cue stick. So bringing it all together, the physics engine builds the table in a world, and then the graphics draws the worlds in a 3D space, which is then projected onto the screen. And then the motion tracker watches the cue ball and the cue stick and waits for them to interact. And then when the collision happens, it repeats. So the collision itself, the motion tracker sees the cue ball and the cue stick collide, and then it activates the vision engine and tells it to run the calculation, and then the graphics engine draws out the action. And then once the action is done, it goes back to watching for a collision again. So let me show you guys how it works. Just a second here. Oh, no. All right. So I run the calibration initially to start it off. It finds that pink screen and adjusts for keystoning. And then I can come up here and I hold this in front of the screen. So this initial calibration of the cue is determining how far apart these markers are. So we can calculate the physics properly within your within the 3-dimensional world on the 2D world. So now once the screen does load up, it has to sit here and wait. So when the physics initially starts, the cue ball is moving a little bit and it has to wait until it stops in order to calibrate it. So that blue circle was it finding the cue ball. And now I can aim and shoot. And now the aiming algorithm requires the cue stick to be stationary for about 15 frames before you can actually shoot. And by stationary, it adjusts for about 50 pixels around where the stick actually is. So if it's within there for 15 frames, again, it'll let you shoot. So once you take the shot, then the ball moves around the table. And you can also, down here on the bottom, there's this very nice little slider. If you don't like the angle you're shooting from, you can go ahead and you can spin the table around so you can shoot from the other side. Once the ball stops moving, gotta wait for it to stop moving again. It really, really crawls to a stop because the friction is really low, because pool balls don't have a lot of friction on a pool table, but it's really hard to simulate in the physics engine. So there it goes, and it's waiting for me to aim again. And let's see if it lets me shoot. Come on. There it goes. It's a pain in the butt to get out of the corners, but yeah, so you can just keep shooting. I haven't actually played a full game of pool on it because it's very hard to shoot when you're standing up trying to angle yourself on the wall, but it is possible to sync the balls, and we've got the little score tracker up there, so whatever name is highlighted is whose turn it is, It shows how many balls they have left of their specific ball. There are darker red balls and lighter red balls to determine, again, which, I guess, scoring team you're on. And the scoring team isn't set until somebody hits the ball. Once the ball is sunk, it will determine which player is connected to which type of ball and then count down their score until they hit the 8 ball. And then they have to pocket the 8 ball, obviously, to win. And if you score the 8 ball early, it does end the game. But, yeah, so that's my senior capstone.
Some time for questions.
Yes, questions. Anyone, everyone, question away. Let me just hop back into presentation mode. Questions? Yes.
Earlier you mentioned that you have to keep the cube in place for 15 frames. At what frame rate does it run?
It's running at 60 frames a second right now, so you really only have to hold it in place for about a quarter of a second. But sometimes it's a little more than that because, you know, physically trying to hold it still for that long can be kind of a pain sometimes. Yeah.
So what is the blue flashing circle?
So the blue flashing, so the tiny little cue ball on the screen, the white of the cue ball, is really hard to find with the image calculations that I'm using, the image processing, the Huff circles. So by doing the blue flash, it basically just makes a larger circle on top of the cue ball that's easier to find. And then by taking that circle and calculating the center of it, I know that's where the cue is. Hayden?
Can you only interact with the cue ball?
Yes, you can't hit the other balls. So if you're trying to shoot over top of the other balls, it won't notice. And you can shoot, I didn't demonstrate it, but you can shoot over the other balls. It will still find the markers when they're on top of the other balls.
Why didn't you like green for the background and maybe red and blue for the two types of balls instead of both red?
They weren't originally both red. They were red and blue, but I ended up going with blue for that marker color, so I just changed it to red, and I never changed it off a slightly darker red than the other red, so that was mostly just me.
Is there any reason the background has to be white?
So the reason the background is gray is because when you project a color onto the screen on top of these markers, it makes it very hard to find the markers. Like originally I had the table as a green, but I could not find these markers because everything was some shade of green. So trying to use the HSV to adjust for that was almost impossible. So I ended up having to go with white. Initially I tried black, which did work relatively well, but white just worked better.
Okay, I have another one.
Mm-hmm.
So architecturally in the code, was there anything interesting that you had to do to get the physics engine to work with the OpenGL?
No, they actually work together quite well. Basically, I just create the physics engine first, and then I pass it to the graphics process, and then every time the graphics process runs, it just does a step in the physics simulation. So the physics simulation is set to step at 60 frames a second, like 60 simulations a second, I guess, and so it runs at the same exact rate as the graphics process, so they're just synchronized.
But they're totally separate?
They're totally separate, yes.
Take one and pass it into the other?
Yes.
It draws?
Mm-hmm. It takes the values of the balls and the table that are in the physics engine and draws those from that. Mm-hmm. Mm-hmm. Yeah.
Why do you use the Java implementation of OpenGL instead of the C implementation?
I used the Java implementation because I knew the Swing framework for building like the layout and stuff of my menus and like building all my controls. Like I didn't use the menu at all because it's easier to quit without the menu, but like building all that stuff in C is much harder. So I went with Java just for the point of being more easily able to build the actual display itself. Mm-hmm. And also the implementations of JOGL and JBullet and OpenCV are all almost identical to C, so it wasn't very hard to take the C code and just translate it into what I needed for Java. So it wasn't really much of a barrier, I guess, to switch between the two. But, yeah. Perry, yes?
So how has working on this project changed you?
Well, it has given me a great respect for lighting and how lighting works in image processing and just how image processing works in general. Image processing is hard, much harder than I thought it was going to be because I figured, oh, you just say, oh, look for this, and then it finds it. But it's not like that. It's a lot harder to do than that. And like getting it to work in here was like a 15-hour process of adjusting the lighting and adjusting my colors and making sure everything was exactly perfect to run in this room. Yes.
Did you have any troubles from the sync?
The sink, no. I was concerned about the sink when I came in here at first, but by putting the camera there, I'm able to keystone it a little bit so that the sink's not in the way. It doesn't actually, the sink is not actually in the frame. So yes, I was worried that I was gonna have to come in with like a wrench and try and take the sink off, but like, all was good. The sink is still attached, so. Yeah.
Did you consider any other games? Like I guess a little surprised you didn't pick like tennis.
So tennis was my initial thought. In our idea, like processing phase, essentially, that's where I started. But in order to do tennis, I'd have to suspend a projector above a tennis court, and that's really hard to do. Like the projector would have to be very, very high in the air, and same with the camera. The camera would have to be with the projector way up in the air, and there's physically no way for me to do that. I don't have any resources for that.
Could you do it kind of similar to how you have it here, where
I guess, but
you could do the virtual net and just kind of stand in front of it?
yeah, and play I guess I didn't think about doing it that way. It'd be like very short court tennis, but yeah, you could theoretically. It'd be almost like,
There would be a sink in your way.
yes, there would be a sink in the way. Yes, I didn't think about doing that. I got to this idea, I guess, before I had already left the tennis idea behind. But yes, tennis was initially my initial thought with this project, because I wanted to do something image processing related, because I think it's interesting. Anyone else? Any more?
Questions? Wait, now let's do it.